In Unit 0, you learned what exponential functions were. In Unit 0, we graphed exponential functions as these things that were like going along, and then they would exponentially get bigger. They were exponentially increasing. And then there were ones that were exponentially decreasing. Both of these were exponential functions. In this unit, we're working entirely on exponential functions. That's why section 1 was on exponents, negative exponents, and 0, exponents of 0. An example of an exponential function, here's the graphs of an example, here's an equation of an example. Y equals 3 times 1.07 to the x power. This is an example of something that this might be how much money you started with. This might be that you are earning or paying 7% interest on something. In real life, when you become an adult, if you ever take a car loan or some money out on a credit card, you will pay so much in interest. This is kind of the equation that they use. It's based off of this equation for how much money you would owe. And literally, how much money you can earn or how much money you could owe is the same graph. One's usually steeper than the others as far as earnings and versus how much you pay. Just so you're aware of that. If I want you to be able to recognize an exponential function, look for the equation that has a variable in the exponent. So if I gave you two choices, don't write this down, just look at this as a choice, okay? Y equals a, b, x, and I have y equals mx plus b. I have two choices. I have choice A and I have choice B. Look at these two choices. One of these is exponential and the other one is linear. Do you know which one is exponential?
Yes.
If you know, tell the person you're sitting next to which one is exponential. And I heard lots of you say that this was the one that's exponential, and you are exactly right. There are questions, literally, is this exponential? Is it not exponential on your worksheet? So that's an easy equation for you to know. Look for the one that has a variable in the exponent. All right, how do we graph exponentials? The best thing you can do to graph an exponential is to create a table. So if, thank you, let me tell you where you sit. You're next to Presley, over there, behind Allie. If I ask you to graph y equals 3 times 2 to the x, there are going to be 4 graphs on your worksheet. And you've never graphed these before, so what I'm going to want you to do is to create a table. And with your table, you're going to make an x and a y, and you're going to pick certain numbers for your x and for your y. If you are in a time crunch, then what I want you to do is use three numbers. But if you want to be more specific, we're going to use 5 numbers. Here are the 5 numbers that we're going to use. The 5 numbers I recommend you use are -2, -1, 0, 1, and 2. That will help you decide what your function is doing. And you're going to always plug those into your x because x is your independent variable. If you are in a time crunch, then I want you to use these middle ones, -1, 0, and 1, and that should get you through enough points to be able to figure out whether it's exponentially increasing or decreasing. Okay? But 5 is going to be good for us. Here's how we do it. We take the -2 and we plug that in to this equation here. 3 times 2 to the -2 power. Just like that. 3 times 2 to the -2 power.
Can we use the function on the calculator?
Yes, you can. If you know how to, that's fine. With this, you can either do this by hand or you can do this with the calculator. I am fine with that. So by hand, 2 to the -2 means you move it down to the denominator and it becomes 2 squared in the denominator, which is 4 times 3, gives me 3 over 4. Which is the same thing as 0.75. If you want, though, feel free to use your calculator. 3 times 2 to the -2 power. These calculators that are on the back wall, the ones I've recommended to you, they can deal with negative exponents, and they can even give you your answer as a fraction or as a decimal, which is really nice and convenient for you when you're going to graph. So then what do? You plug in -1. 3 times 2 to the -1. You can do it by hand by moving the 2 down, which is 3 over 2. You can turn it into a decimal if you would like, which is 1.5. You can plug in 0. Anything to the power of 0 is 1, but just because there's a 1 doesn't mean you can't multiply it by 3. You have to multiply it by 3, which makes that 3. And so I'm starting to see a pattern here. 0.75, 1.5, 3. I think I know what the next one's going to be because I can do multiplication. Let's plug in the 1. 3 times 2. Let's plug in the 2. 2 squared is 4. 4 times 3 is 12. And I'm starting to see that this pattern is doubling. If you were to take these and plot them on your x-axis and your y-axis, -2.75, -1, 1.5, 0, 3, 1, 6, 2, 12, it's off the page. I can now tell it's exponentially increasing. I can tell this is doubling. When you are asked to graph, what you're going to do is create a table. Use the table. If you want, Blake asked, he says, can I use the table function on my calculator? Absolutely. So I want to do a quick review. If you want to punch this in, there is a way on the calculators to do it. Let me show you just to review. You can type in a table, which is number 7. You can type in your function, 3 times 2 to the alpha x power. Where do you want to start your table? What did I start at? -2. Where do I want to end? I end in at +2. Do I want to count by? What do you want your steps to count by? I count by 1s. And then your table function, if you can't see that, -2.75, -1, 1.5. It actually can plug in all those numbers for you and give you this table if you want to use the technology. I'm okay with that. That's why these are nicer than the ones that are on your cell phones. They do more, by the way, believe it or not. I don't know if you put this on there, but this is just like number 15 on your worksheet. Please make sure you write that down. Then there are other problems. Problems that say evaluate. These ones are easy. These ones, I don't think that I really need to even show you how to do it, but I'm going to have you write it down anyways because it's like number 10. If you don't know what the word evaluate means, it means plug it in and simplify. Y equals 5 times 7 to the x power for x equals 0. It's exactly like number 10. I bet you if you were to try to evaluate, you might get the right answer. Go ahead and try it. If you get it wrong, we'll cross it off. We'll write down the correct answer. Let me give you 30 seconds for you to try it. Try it. Now I'm curious, how many of you got y is equal to 5? Raise your hand, please. Oh my gosh, that's 80% of my class. Good job. I told you. I knew a lot of you would get that correct. And that's how you're going to do problems like number 10 in that category. You just plug it in. Two other things that you're going to have to do is solving. I have two last examples. When we're done with these examples, we'll be done with your notes. When it says solve, what I want you to think of is finding things in terms of the same base, meaning the same bottom number. Solve, find the same base. I'll show you what I mean, because you haven't done problems like this before. If I have a problem and it says 2 to the x power is equal to 16, you won't learn how to get rid of that 2 using algebra until like math 3. It's called using a logarithm. Totally different concept than what you're used to. Logarithms you won't see until math 3. So what we're going to learn here is how do I do this kind of problem without logarithms? How do I solve this? 2 to the x equals 16. Well, what you need to do is figure out 16 can be written as 2 to what power? Think of it like this. Think of it like this. You know what 2 to the first power is. That's 2. You know what 2 to the second power is. That's 4. You know what 2 to the third power is. That's 8. 2 to the fourth power is 16. So I could rewrite 16 as 2 to the fourth power. And if 2 to the x is equal to 2 to the fourth, then those exponents have to be the same since they have the same base. What you're going to do is you're going to find ones that have the same base to find what the exponent has to be. I know that might look like a lot of work, but a lot of you did that in your head already, didn't you? Okay? They won't be this easy. They're going to be disguised. So this example is a basics. It's like number 19. But a harder one will look like this, which is like number 22. This says 4 to the x plus 6 is equal to 70. What we're going to want is we want to get this little piece by itself, this 4 to the x power. We want to get that by itself. What we don't want is this plus 6 next to it. And just like you learned way back in Unit 1, you can move this to the other side by doing the opposite. What's the opposite of adding 6?
Minus.
And whatever you do to one side of the equal sign, you do to the other. So if I subtract 6 and subtract 6, what does that make it?
64.
Okay, so then you have this. 4 to the x power is equal to 64. So right off the bat, you're not going to see it until you do the first step, and then you might see it. And if you're not sure what 64, how you get the x by itself, you're going to think about, I need a multiple of 4, and I need to get to 64. You can use your calculator if you need. Mode number 1. And I can actually type in 4 to the first, which is 4. You can't even see that. Let me try to get it to the right angle. There we go. There's the right angle. And then what I do is I can go back up here and do 4 to the second. And I can go up there and do 4 to the third. I need to find the base of 4. Since I have a 4 here, I know it has to have a base of 4. I know 4 to the third is the same thing as 64. Therefore, the exponents have to be the same. Does that make sense to you?
Yes.
Okay. We're going to stop our notes right there.